Hey everybody, this is Larry. This is day 4 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about today's farm, today's video, and leave a comment. Let me know. Yeah, I am right now on Sunday evening here in New York. And I am 48 hours, maybe minus 30 minutes, so 47 and a half, even to be really precise, into my dry fasting, meaning no water, no food, no nothing. So I'm a little bit I feel like I'm a little bit tired right now, to be honest. Or mentally I'm great, but just like my limbs are just so like not as energetic, because I am the type that usually wants to go like do a lot of stuff, but right now I'm just, I don't know, not so much. And I only walked like 6 miles today outside, so I didn't even do a full one. But yeah. So we'll see how this goes. I say my brain is good, but we'll see if this problem actually shows that. Anyway, let's take a look. And also, given that we've done this problem before, I will do an extra bonus random problem afterwards. So definitely, yeah, hit the subscribe button if you want to do, another problem with me, and let's do it together. That's the best part of these videos, I think, if you ask me. And come on the Discord. I don't know. I'm just saying a lot of stuff. Anyway, today's problem is 948 bag of tokens. So you start with an initial power, initial score of 0, a bag of tokens, and token supply denotes. Okay, that's a typo, I guess. Donates the value of the token, denotes the value of the token. All right. Your goal is to maximize the total score by strategically playing these tokens. In one move, you could play an unplayed token in one of the two ways. Face up. Say what? In one move. Okay, and you could play any number of moves. So you could do face up. If your current power is at most token sub I, then you may play token and gain 1 score. If your current score is at least 1, you can do okay. Do I have to do this in order? I guess we'll look. So we could play the second one first. Okay, so basically for each token we get to choose. We have, what is power? Okay, we have an initial power, and given the power, we can spend it on tokens. So basically we have two things for each token. We have either getting a score or get or spending a score to get power. All right, so I think that basically means that because these tokens are pretty much the same thing, and you could get a score for each one. This lends itself to a very kind of, I want to say obvious, but I don't know if that's true. But it's just like a very greedy solution, right? And why do I say this? And greedy is always hard for me, as people who watch my channel knows. And I don't know why I'm speaking stutterly like this. Maybe it is the brain processes running on ketones and all these things. But it makes sense that given that you want to maximize the score, you want to play as many face-ups as possible, right? And in this case, if you want to play as many face-up as possible, and it costs power to play tokens, then you want to basically you want to go cheap on the cheapest power as possible. That's basically the answer, right? Yeah, and it even like gels if the other face down, so it's not a really decision, because basically you could gain a power for a token. And of course, if you want to gain power for a score, you want to spend tokens that give you the most power. So the first things that I want to do would be to sort, right? Because now you have the face up tokens on the left and the face down tokens to the right. We can do two things really. We can do a binary search, I think, probably. I haven't really thought about it that much about it, because it doesn't really matter, because this is already n log n because of the sorting. So you could do a binary search, but I can just do a linear thing, right? So what does it mean to do a linear thing? Yeah, and in a way, it is. Let me double check the constraints. I mean, I guess with 1,000, you can actually do 1,000 square, which is a little bit awkward. I feel like you can probably do a little bit smaller than that, but maybe I'm wrong. Because yeah, maybe you can't do it in a binary search kind of way, because I think the thing is that the with this problem it's path dependent a little bit. I think in the long run it's not path dependent, but it just means that it's path dependent because you may get into a state where you cannot keep going, right? What I mean by that is that you can get to zero score, so then you cannot make this move, even though making another move may give you a token or something like this, right? So I think that's kind of the tricky thing. And you can't even play this if in the beginning on the cheap ones. And yeah, you still have zero score, so you can play this and you cannot play this, right? So yeah. So I think but the idea is still the same. Maybe the order it's going to be tricky, but I think the greedy thing is good, right? So let's just start with best is equal to 0, and score is equal to 0. So current is equal to power. That's the thing that you start with. So then now we can say while true, and then maybe in a greedy way, whenever we have power, we want to get a score. So we go, yeah, how do I want to write this? I know that people kind of, I don't know. Some people ask me why I like writing it this way, even though you can just use like a pointer. It just makes it easier for me to kind of not deal with off by ones with indexes and stuff like that. It's a deliberate way. It's a little bit weird. Maybe on an interview I would clean it up, but on the contest I definitely write it this way so that I don't have to worry about off by ones, right? So then here because then now I can write, and maybe I can just write like while length of tokens is greater than 0, because otherwise. But yeah, if token sub 0 is less than or equal to current, then we want to just take it because this is the cheapest thing you can get anyway, right? And then score with and then token stop pop left, right? And then we continue. So then we keep on going as long as we can. And then now, yeah, and then maybe here we have like a best, so then we can just update the best possible score that we're getting. And then now if we cannot get the front, then maybe we'll spend the score. We don't know if this is always going to lead to a better solution, which is why we have this thing here, right? So then here with score is, because by definition we are here, that means that we cannot buy a token, and so we need more money anyway. So if score is greater than equals to 1, and tokens of the back is actually we don't even care, right? We just get it, fine. Then here we do token stop pop, and then we add that to the score. And actually I guess we can just do it here for symmetry reasons, right? And then we continue. Otherwise we break, because then here we're done because we can't take the first one and we can't take the last one, so we have no more moves, right? And then we return best, and I think that should be okay in the greedy way. Maybe not though, apparently. So okay, so we play 100 because our powers, and then at 100 we have 1 token. We spent 1 score to get 400. That should be right. And then now we have 0 score and 100, right? So I mean, my idea is right, maybe my implementation is wrong, which happens. So yeah, so here we go to score best tokens. Let's print it out real quick. Okay, so we start with this. We have no score, right? So we ate the 100, we ate the 400. I guess we should also update the current. Did I miss something? Maybe I missed something, I don't know. Yeah, we have 500 with 300. So 300, this is good. Do I have off by 1? because this should go to, oh, because this goes to continue, and then while this is continued, this loops out. So okay, fine. I guess we should always just update it here because this is the only time we increase the score, so this is the only time this can update. Okay, so it's silly like order of operation thing. Let's give it a spin. And yeah, 4-day streak. Yeah. Ooh. Kind of tricky problem to be honest. Because greedy problems are always tough. And the way that I think this is more of a sorting problem, which I guess sorting problems are usually greedy problems in a way that, you know, you have a structure that you can exploit for greediness. But I think this greedy one makes sense. I mean, you could like you could prove the greedy if you like by also the exchange argument by not taking the smallest, and then you can. I mean, it's just like a quote unquote obvious thing because why would you, if you think about this problem in terms of like money or something like this, and you know you have two apples, you have an apple that's $100 and an apple that's $200. Of course, you buy the one apple that's $100. It's just like way, like you know, like maybe you could ask for a proof, but I feel like, you know, if you want a strict proof and you go and go like, okay, 200 is greater than 100 is your proof, right? Right. So so I think this kind of makes sense, and this as well because, yeah, it's just that might not lead to an optimal solution, which is why you know update that here. Anyway, that's what I have. My hair's a little funky. I just noticed. I don't know. But yeah, I'm gonna do another one. This is clearly n log n from here from the sorting, but and all of n space also from the deck. But everything else is pretty straightforward and linear. So yeah, linear time, constant space outside the sorting. But yeah, that's all I have with this one. Let me know what you think, and yeah, let's get another problem going. Stay good, stay healthy, to good mental health. I'll see y'all later. Take care. Bye bye.